This is the first of two videos in how to find the equation of a line, given 2 points. Before we start, let me remind you of some general information about graphing, just to refresh your memory for how this works. If we're given an equation and we want to produce a graph, one way to do it is to find points that make it true. For example, 4 plus 1 is 5, so we say that the point 4, 1 satisfies or is a solution to this equation. We call that an ordered pair. We can graph that ordered pair on our x and y coordinate system as usual. But of course, 4 plus 1 being 5 isn't the only way to make this equation true. It's not the only point on this graph. This equation is also true when x is 2 and y is 3, of course, which we could plot as well. And if we continued to find true points on this equation, and those aren't the only two, by the way, if we continued to find true points, they would be scattered about, but we would quickly discover that they all formed a straight line. And so, when we draw this line here, we're really representing all the solutions to this equation. That's not what today's video is about. That's just a brief reminder of how graphing works. And notice here, the equation is like the problem, and the line is like the answer. Well, how today's video will go is we're going to show you how to work backwards. In other words, given a line, how can we find the equation that represents that line? So in today's video, the line will be the problem, and the equation will be the answer. Here's a specific example. There's a line that contains these 2 points, and what we want to do is we want to find the equation of that line. Let's graph it first. Here are the 2 points. Here's the line containing those 2 points. This is the line that's given in the description here. And one thing that can be really helpful when trying to find an equation is first finding the slope. Now, you may not have heard that word in a while, so let me remind you. A slope is a measure of how steep a line is. But let me be more specific. Let's enlarge this small portion of the graph just to get a better view, reminding you that slope means for every 1 unit increase in the x variable, what's the resulting change in the y variable? In this case, the slope appears to be 2. Now, if you have excellent slope finding skills, you don't necessarily need an equation. You can look at a line and know its slope, and that's fine. But most brains don't work that way. Most people do better relying on a formula for slope rather than basing it on the appearance of the line. So here is a formula that we can use for slope. Now, you'll notice in this formula it makes references to first and second, this or that. The meaning of all that is this. This is my first x, first y, second x, and second y. In other words, it's the x's and y's that are given to me in the original problem. Now, this formula can be a little cumbersome to write. You may prefer this version of it instead. M, by the way, represents slope, which I've never been able to figure out why, but that's a mathematical choice we'll stick with. And we can use the numbers in the problem to find the slope, as shown. If this looks familiar to you, great. If not, let me remind you how this works. The 7 was my second y. The 3 was my first y. The 6 was my second x. And the 4 was my first x. So you essentially plug the numbers in from the problem into this formula, and then just do some basic arithmetic. We all know what 7 minus 3 and 6 minus 4 are, and we all know what 4 divided by 2 is. Great, and now we have m, which again represents the slope of this line. Well, why is that helpful? The problem didn't ask us for slope. Well, it's helpful because the problem asks us for an equation. This formula you see right here is the basic equation of a line. It's technically called the point slope form, but I don't want to obsess over the name today. It's good to memorize this. This is the one formula that will always get you the equation of a linear function. Now, I plug in all the numbers that I know. Let me clarify where these came from. The 2 came from the slope that I just found. The 4 came from my first x. And the 3 came from my first y. It's also worth noting that the x and y without the subscript 1 under them, those are the variables. Don't replace them with any particular numbers. We need an x and y to have a valid equation, so leave those alone. One thing worth noting here, or really questioning, is what if we hadn't graphed the line in the first place? Could you have done all of this algebra without ever having a picture? I, for one, could have, and lots of students can too. You may want to consider not drawing the graph, because it isn't really a necessary step for this problem. It does give you a nice perspective, but it's not needed to do the algebra. So what have we done so far? We have the equation of the line. I thought I'd just move it up and give myself a little space to work. And if all they asked us for was the equation of the line, and there were no qualifiers on that, just equation of line, period, we're done. There's nothing else to do, and that's the answer. But you're unlikely to stop here, and here's the reason. Most professors or textbooks or websites or whatever's motivating you to do work don't want the final answer in this format. Not that it's wrong, but it's a tradition to either answer in what's called slope-intercept form or what's called standard form. But which one do you have to use? Well, that depends again on the individual assigning you the work in the first place. Everybody has their preferences, but I'll show you how to do both. First of all, let me give you the formulas for these formats. And if you're wondering where all these strange letters came from, notice everything in red. Those are just mathematical placeholders to remind us that there are going to be numbers there. So the letters themselves aren't important, but when we say that an equation is going to be in slope-intercept form or standard form, we mean it's going to be formatted in exactly that way with numbers where you see the red pound signs. Okay. First thing that I would do to my equation to get it into these forms is distribute the 2 on the right just to make the work easier. Distributing the 2 is easy. You'll notice I did that here. And once I've done that, I have to pay particular attention to the format that I want. Let's look at the left half of the screen first, where it says y equals mx plus b. To get it into that format, I need to get the y by itself. The best way I can do that in this case would be to add 3 to both sides and cancel out the negative 3. That leads me to this equation, and that is, you'll notice, in slope-intercept format. And if that were the format you were looking for, you'd be done with this problem. But suppose, on the other hand, that you were working in a course that required you to put your answer in standard form. Notice the right half of the screen. I might want to subtract 2x first, because you'll notice that standard form, if you look at the equation with the red letters, standard form has the x and the y term both on the left, not on the right as it is in my current problem. So by subtracting 2x from both sides, I'm eliminating the 2x on the right, and essentially bringing it to the left. Further, by adding 3 to cancel the negative 3, you'll notice I now have this in standard form, which is just a fancy word that means you have an x term, a y term, an equal sign, and then a number. Now that's a completely valid answer to this problem, and now you see 2 valid answers, and essentially I am done. Although there's one afterthought I'd like to throw at you here. You may encounter certain situations where you'll see somebody multiply an equation by -1, and the reason never seems very apparent. I've often gotten the question, why are we bothering to do that? Well, notice what happens when we do that. Let's start with that. multiplying by -1 essentially changes all the signs. Is that a requirement? Absolutely not. But it does clean up the equation, doesn't it? If you compare the bottom two equations on the right, the one on the very bottom definitely looks neater. So I'm not saying that you have to do that. I'm saying you may opt to do that just for neatness sake. In case you've lost the bigger picture in all this discussion of algebra, let me point out what's happened in this problem. We were given the description of a line. We were given 2 points on a line, and that's all we knew about it. And we were able to deduce through algebraic work that the equation of that line could be in one of two formats. That's really the point of this problem and this video. Let's look at another example. Now, this problem is a little trickier, not because the procedure is any different, but because it involves negative numbers, and as you'll notice in a few minutes, it's also going to involve fractions, which can be a little annoying. I'll show you how to deal with that. So let's graph the line. Again, not required, but it does give me a good image of where this line is. Here are the 2 points that I've been given. Here's the line containing them. It's that blue line right there that I want the equation of. Again, one way to find the equation of a line is to start by finding its slope. I'll use my slope formula to do that, just like I did on the previous problem. Here I've got my first x, first y, second x, second y, and you essentially just plug them in as we did before. Notice there's my second y, first y, second x, first x. Do some basic algebra. Here I've got a division problem. Remember, a positive divided by a negative is a negative. And also don't forget to reduce when possible. If you think back far enough, you'll remind yourself that fractions do reduce. In this case, 12/9 reduces to 4/3. Would it be wrong if I didn't reduce? Technically no, but it would be messy and make work harder for you in the coming steps. So the whole reason we found the slope was to take the basic equation of a line and plug it into that equation. Here would be my result, and again notice I got the -4/3 as the result of my slope calculation that was just done, and I got my first x and my first y straight out of the original problem. Again, I'd like to point out that the x and y without subscripts are the variables themselves. Don't plug numbers in for those. We need those in our equation. Another thing worth examining is that the graph itself, while helpful to some, may not be helpful to others. If you find these problems easier without a graph, then you're by no means required to graph them. So now I've got the equation of my line. Let me make some space. And let's continue this same problem by examining the two formats that I could convert this into. Now, before we do that, I'd like to remind you, if the problem simply asked for the equation and didn't specify that it wanted it in any particular format, then you are done right here. Problem over. That's unlikely to happen. Most platforms, professors, textbooks, whatever you're working with, will expect the equation in slope-intercept form or standard form. So let's continue along those two lines. Just a reminder, the format, what those mean. And again, if the letters look strange or confusing, just remember they just represent numbers. Those letters are just there to remind us our final answer will have numbers in those locations. So I would take this equation and I would distribute the -4/3 here just like I did in the previous problem on the right half, and that will give me this. Now this may look a little strange, especially if you haven't done fractions in a while. Let me point out a few things that may seem obvious to some but not so obvious to others. First, the act of subtracting a negative is the same as addition, just a reminder from the past. Here's something even more complicated. Where did these plus 4's come from? Well, they came from negative 4/3 times negative 3. Let's take a brief excursion back into fractions so I can remind you how that works. When you multiply a negative times a negative, you get a positive, so I can disregard those negatives. But furthermore, when you multiply a fraction times a whole number, here's a little known fact, the whole number only multiplies by the top of that fraction, not the bottom. 4 times 3 is 12, of course. And lastly, we do our division, 12 divided by 3. And that's where the plus 4's came from. Now let's continue to get these problems in the format requested. First, focus your attention on the left half of the screen, slope-intercept form. If I want this in slope-intercept form, I need to get the y by itself. Best way to do that is to subtract 5 from both sides, canceling out the positive 5, and leading me to my answer for slope-intercept form. If the problem you're working on asks for slope-intercept form, then you're done. No further work required. But what if it asks you for standard form instead? Well, something I didn't mention on the last problem, telling you now, fractions aren't allowed in standard form. Why is that? Just an old math tradition. No logical reason for it at this point. What you need to know is that the tradition is not to have fractions in your standard form answer. So I'll show you a cool algebra trick to get rid of fractions. Whatever number you have in the bottom, also known as the denominator, the cool trick is multiply the entire equation by whatever that number is. And the next thing you know, you won't have any fractions. Now let me guide you through step by step here. 3 times this is that. 3 times this, obviously that. Here's the difficult one. 3 times this is that, which is similar to the fraction problem we saw a minute ago. And of course, 3 times this is that. And the trick of multiplying the entire equation by the denominator is an awesome trick for clearing fractions. Now we have no fractions to deal with. However, you'll notice we're still not in standard form because we have an x on the right side of this equation. So let's add 4x to get rid of that. And let's further subtract 15 to get that constant term on the right. And after all this algebra, we now have our equation in standard form, as well as the previously achieved slope-intercept form. Again, it's worth noting the big picture in case you've got lost in all the numbers. What this problem was about is we were given the description of a line and asked for the equation. Through the algebraic deduction process, we were able to get 2 forms of that equation, as you can see on the right half of the screen. And that's the point of these problems. So, let's summarize. You're given 2 points. The first thing you should do is find the slope using this equation and all 4 of those numbers. Once you have a number for your slope, take the general equation of a line, plug whatever you got in for slope here, and plug in your first x and your first y here, and you will then have the equation of the line. Then, using algebra, we can convert that equation into either slope-intercept form or standard form as desired. And that completes the first of 2 lessons.